This video will explain unit calculations. In other words, how we can calculate what the units will be for a particular equation. There's three fundamental units that we use in physics, or that we have been at least in our courses, and those are displacement is measured in meters, time is measured in seconds, and mass is measured in kilograms. Now we know that the formula for velocity is equal to delta D over delta T. Now if we ignore numbers and we just look at units right now, okay? Displacement measured in meters, time measured in seconds. Therefore, that we know that a velocity has to be measured in meters per second. Okay. Acceleration is equal to delta V over delta T. We just found out velocity is measured in meters per second, divided by time measured in seconds. So acceleration must be measured in meters per second squared. Another one that we took in the last unit was force. We said that force is equal to mass times acceleration, which is equal to mass is in kilograms, acceleration is in meters per second squared. So we have kilograms times meters per second squared equals kilogram meter per second squared. We define that as a Newton. Okay? A Newton is a derived unit. It's not a fundamental unit. Fundamental units can't be derived from other units. In other words, distance, time, and mass. They all are measured in fundamental units. However, force is measured in a derived unit, something that comes from other units of measurement. In this unit, we're now looking at work, which is equal to force times displacement. So force is in newtons times displacement in meters. We know that a newton is a kilogram meter per second squared. Times that by a meter. And work is measured in a kilogram meter squared per second squared, which we define as a joule. Joule is another derived unit. You are also looking at power. Power is defined as work over time. Work, we just learned, is measured in joules. So joules over time. Joules, time is in seconds. We know that a joule is a Newton meter. And we know that a Newton is a kilogram meter per second squared. Times that by meter, divided by seconds. And power is measured in kilograms meters squared per second cubed. And we define that as a watt. Now, there's two other equations we're going to be talking about in this unit, and that is kinetic energy, EK, is equal to 1/2 mass times velocity squared. Now, because the half has no units, we can ignore it in a unit calculation. You can't ignore it when you're actually calculating and working out a problem, but when we're just looking for what the units of EK is, kinetic energy is, we can ignore the half. So we know that it's mass, mass is measured in kilograms, velocity is measured in meters per second. Now that is squared, right? It's the velocity squared. So we get kilograms. And when you square something like this, you got to square both numbers. So we square the meters, square the seconds. It equals to kilogram meter squared per second squared. Now if we look back, a kilogram meter squared per second squared we defined as a joule. So kinetic energy is going to be measured in joules. Finally, the last equation that we looked at, that we are going to look at, is the gravitational potential energy, EG. Okay? In other words, that's the energy that an object has, the potential energy it has, due to the gravity of Earth. So that is measured or calculated by mass times g, the acceleration due to gravity, times the height that it is above the center of the Earth. Okay, so mass is kilograms. G, defined as the acceleration due to gravity, and you'll learn that right away here in the unit. Well, if it's an acceleration is measured in meters per second squared. So meters per second squared. And height, well, height is a distance, so that's going to be in meters. And work this all out, and we get kilogram meter squared per second squared, which we know is defined as a joule. So gravitational potential energy is going to be measured in joules as well. The reason that these calculations are so important is that when you're given a question and it asks you for what is the speed of the object when it hits the ground? Well, speed or velocity is measured in meters per second. If I don't get meters per second in the end, something went wrong in my calculation. Either I had the wrong formula or I plugged in the wrong variables. If you work out your units for every equation and you're not getting the right units in the end, you know you've got a problem. Also, along those same lines, if you're given a set of if you're given a set of variables in the equation and you have to figure out what equation to use, well, if you're given a distance at a time, in other words, a unit that's measured in meters and a unit that's measured in seconds, and you're asked to find the acceleration, you can't use this acceleration a equals delta v over delta t, because you need something that's in meters per second and something that's in seconds. So just keep those things in mind, and it's a good idea to work through these and to know these off by heart. You should know that a Newton is a kilogram meter per second squared, that a watt is a kilogram meter squared per second squared, or a joule, or a Newton meter. All those things you should know off by heart. It just makes calculations on an exam much easier if you know what the units end up as, because it can help point out a mistake in the question if you made one somewhere.